Good evening, and welcome to Beckman Auditorium. Oh, that sounds, for me, a lot better. I don't know if you were hearing a double echo or not, but I was. This is much better for me. Welcome all of you to a very special Behind the Book. Tonight we are going to all be introduced to the warp side of our universe, co-authored by Kip Thorne and Leah Halloran. And for those of you who are watching this being streamed, this is going to be the last time that we're going to be doing a hybrid event. From now on, they're all going to be live. We'll record them for future viewing, but if you want to be in real time with it, you're going to have to register and show up in the audience, and that'll also enable you to be able to ask questions. And tonight, you're going to see a QR code on the screen. You can get that QR code. It'll get your cell phone to the question page. It's Slido is the name of the organization that helps us get the questions. And then we'll be feeding questions to our two authors at the end of the evening. I want to start off by thanking the Caltech Employees Federal Credit Union. They've been a sponsor of our events for years and continue to be very, very supportive of all of the live performing arts and lecture series and book series, movies that we present here. And I'm very, very grateful for their support. And also to the Friends of Beckman Auditorium. And the Friends of Beckman Auditorium not only help support events like this, but they're also helping us do events where we are bringing young people into Beckman Auditorium and introducing them to science, sometimes introducing them to the arts. And so their support, and I think some of you in the audience are friends of Beckman Auditorium, and we want to thank you for the support and encourage the rest of you to join. If you want to find out more about Caltech's presentations, you can go online to events.caltech.edu. Sign up to get on our mailing list, and you can also find out about becoming a friend of Beckman Auditorium and about the many different lecture, film, and performing arts programs that we do have coming up here. The next event is going to be very interesting. It's a Watson lecture on December 13th, and it's dealing with the question of wearable biosensors. Professor Wei Gao of the Medical Engineering Division is going to be presenting that Watson lecture, and we encourage all of you to come here for that one. We've got Professor Bethany Ellman doing a lecture on the 31st of January that is going to be talking about her work looking for evidence of once there being water on Moon, if I'm not mistaken, and she is part of our Keck Institute for Space Studies. On the 30th of January, we're going to have former County Supervisor Zev Yaroslavsky here, and he is going to be talking about his book, Zev's Los Angeles, with Caltech professor Mike Alvarez, and we encourage you to come back for that one as well. One thing I have forgotten to mention in previous events, and I create a separate page just to make sure that I don't forget it, is to remind you all to turn off your cell phones and to remind you where the exits are in case there's any need to get out in a quick emergency, which is yet to happen here. So, the warped side of the universe is a real it's a new trendsetter. It's a new kind of a way of looking at a production of a book where an author and an artist are working close together to the point where it becomes a seamless experience for the two of them as they've created this incredible book for us. We're going to have them for sale at the end of the evening. You'll be able to just go out the main doors and go to your right, and you can buy a book, and they'll be at a table there to autograph them as well. There's also going to be a print on display and a QR code that you can pick up and find out about purchasing copies of this print that was created by Leah Halloran. Leah is the chair of the art department at Chapman College and is been producing art for all kinds of exhibits. You can actually see her work as well in Cahill, the building just on the other side of California Boulevard that is part of the Caltech campus. And we've got a big permanent exhibit of her work up in that room, that lobby area as well. Kip Thorne almost needs no introduction. Nobel Prize winner. They are in the middle of a combination book tour, and he's even squeezing in lectures at various universities as they're traveling. He's traveling around the country. My wife and I went to Logan, Utah a number of years ago for an opera event, and as we were taking a walk around town, we came across Thorne Boulevard. And I talked to him about it, and he said the city of Logan has promised to name a street after every Nobel laureate who comes from Logan, Utah. So, could be quite an experience. But now we get to have him here in person. Let's welcome both Kip Thorne and Leah Halloran.
Hello, good evening.
Good evening. Can you hear us?
Great.
My favorite quotation from Stephen Hawking. Thank you for the introduction, Michael. It's a great pleasure to be with you all today in this very friendly home crowd. I love Caltech. Have loved Caltech since I first read about it in Time magazine in 1954. That was before anyone here except me was born, probably. So it's wonderful to be here and be able to talk about our collaboration and the book it produced.
So tonight we're going to have a conversation about how we made the book. I love the title of this series, Behind the Book. We'll get into it. But first we thought we'd do a little reading from the prologue of the book for you.
And the point of the prologue is to explain what the book is all about. So that's why we've chosen to do a reading from there. Our universe is varied and vast. Galaxies, planets, stars, and moons, quasars, pulsars, and magnetars, all made from atoms and molecules, just like you and me, and all that we hear and touch and see. Our universe is also endowed with a marvelous, shadowy side that is warped, phenomena forged from warped space-time. Witness the ravenous, fat black hole that Leah here depicts ingesting her wife, Felicia, who does happen to be here this evening, and we apologize, Felicia.
Although this warp side is entwined in the weft of our matter-filled universe, its stars, its planets and nebula, its galaxies and its comets, we humans never saw it until just recently. Why did we never see? Warp space-time cannot produce light or other signals that yesterday's technology was able to perceive. So now, how has that changed?
A very long time ago, 1 billion years in the past, while here on Earth, multicelled life arose and spread around the globe. But in a galaxy far, far away, two spinning black holes danced around one another, rippling the fabric of space and time. The ripples, we called them gravity waves, sucked energy from the hole's orbit, so the holes spiraled inward, eclipsing each other toward a climactic collision. The holes at half of light speed catastrophically collided and merged in a brief cataclysmic storm of writhing and twisting space-time that brought the waves to crescendo.
The climaxing gravity waves from this catastrophic collision surged out of their birthing galaxy and into interstellar space. Spreading across our universe for nearly 1 billion years, they stretched and they squeezed all that they met, stars and planets and nebula, in patterns that encoded a portrait of their birth, colliding holes and space-time storm. Then 50,000 years ago, when humans shared Earth with Neanderthals, the spreading and weakening gravity waves sailed into our spiral-armed Milky Way, our galaxy, our home.
On September 14th of 2015, near the Antarctic peninsular tip, the waves flying upward plunged into the Earth, through air and then oceans, then rock. Whispering up through Earth's bowels unscathed and emerging just north of New Orleans, the gravity waves came face to face with a complex and huge L-shaped invention designed and built to perceive them, LIGO, the Laser Interferometer Gravity Wave Observatory. Flowing through LIGO, the gravity waves stretched and then squeezed microscopically two very long beams of bouncing light that extracted the portraits the waves had encoded, colliding holes, and space-time storm.
This tiny shudder in LIGO was momentous for the whole human race, our very first moment of contact with the warp side of our universe. The warp side of our universe is home to many beasts, beasts that are forged from warped space and time, beasts that may well include black holes and wormholes, time machines and cosmic strings, gravity waves and singularities, our universe Big Bang birth, and many other beasts, wondrous, weird, and wild.
For decades, I, a beast, materially composed, have been consumed by quests to fully comprehend this warp side of our universe. How? Through tricks of mathematics and computer simulations, probing Albert Einstein's relativity equations. And in a 1,000-person fleet of scientists and engineers, we've pursued a quest to invent, construct, and utilize our behemoth LIGO for humans' first encounters with the warped side of our universe.
Big questions have driven these warp side quests, some that I'm sure you have asked yourself, and some you likely have not. How did our universe begin? Can anything travel backwards in time? Can advanced civilizations build wormholes for fast interstellar travel? How does warped space-time behave when wildly, frenziedly writhing like the open sea in a storm? How does the warped side of our universe impact the material side, the side that we humans see and feel?
In this artistic, poetic book that will undulate in your hands, Leah and I use paintings and verse to shed some glimmers of light on all of these big questions. But first, we shall pause to explore the quintessential example of a beast who inhabits the side that is warped, the black hole. And that's how our prologue ends. Now, a black hole has a rich variety of features, all made from warped space-time, likely far richer than you have ever heard of or imagined before. In fact, we've learned a great deal about these rich features made from warped space-time that we didn't know before. We've learned about that while Leah and I were working on this book through computer simulations that were carried out by a collaboration between Caltech and Cornell that I will be talking about a little bit later and that are discussed in some detail in this book. The first chapter of our book introduces some of these features of black holes one by one and then summarizes them in the following way. So this is the conclusion to the first chapter, which we're not going to read to you, but it's just the summary. It will contain a number of concepts of aspects of the black hole that are made from warped space-time, some of which you've heard of and some of which you probably have not. So we'll now move over to these chairs and sit down, and we're going to have a conversation with each other. Every place else that we have been talking about our book, we've had somebody who basically interviewed us about it, a moderator. We decided for Caltech, which is a very special place for us both, that we would prefer just to have a conversation between the two of us because we can control the conversation and really carry it precisely where we'd like to carry it. And so it's an experiment. We haven't tried to do this way before, and if we sort of smash it up badly, you'll forgive us, I'm sure.
Or they could ask all the real questions in the Q&A.
Yeah, or you can ask all the real questions in the Q&A. So let's, oops. No, that's got to go in here. If you put it in there, it's going to be a disaster. We did a lot
to
of
a good start
a lot
here.
of experimentation to find out what magic combination of things works, what doesn't. Okay. Okay, now let's see. Come. Wow. Remarkable.
We really didn't think this was going to work.
Okay, so Leah, you have connections to Caltech, which people probably don't know about. And I thought it would be nice if you talked about those connections to Caltech at the beginning, since everybody knows my connection to Caltech. So you even have connections to Caltech students.
That's
so
right.
Tell us.
Yeah, so I would say it might be about 8 years ago, I had started making a series of work that was based on a catalog by Charles Messier. And for those of you who are astronomy students, you know this very well. It's almost like the periodic table is to astronomy. And Charles Messier had created this catalog when he was looking for comets. And he wasn't able to find comets, and he was really upset about those, and he wrote very dramatically in his journal, "Things to avoid when out hunting for comets." And I was really drawn to this catalog because I thought it's like a catalog of failure, but what he didn't realize is he was 200 years early to discovering nebula and nearby galaxies. And so I had started making a series about this catalog, and there's 110 of these objects. It took nearly 3 years to paint the entire series. And in the end, I had essentially 220 pieces because the drawings were used to make these photographic positives. So if you've been in Cahill, you know it's a really extraordinary architectural building built by Tom Main. There's not one even wall in the building, maybe in someone's office somewhere. But I was invited to do an installation in this building, and while it was exciting, it also was very intimidating. And so the gentleman on the left here is David Ross. He's an architect at Friedrich and Fisher, and him and I worked over the course of about 6 months to come up with the exhibition design, which is ultimately to cut the works into these discs. And so if you haven't been over there already, there's 110 discs, and they crawl through 4 stories of the building. It was a really exciting opportunity to do something very different. And then in winter of 2022, I received a fellowship through the visual culture program here at Caltech. As I was introduced, I'm chair of the art department at Chapman University, and I teach in the painting and drawing area there. But my real passion is to develop interdisciplinary courses. So I have a couple of courses at Chapman that are like the intersection of art and science, a course called UP that integrates flying. And so for Caltech, I wrote a class called Relative to You, Understanding and Exploring Scale in Art and Science. And this is a slide from one of my students. It was fascinating. I only had science majors, and they all made art projects with me for the semester. So I also have grown to really love the community here at Caltech. And so, even just over the years collaborating with Kip, I already feel already at home here.
So I think next we should talk about how we first met. And Leah has a story about how she met me before I ever met her by some number of years. So why don't you go ahead and tell your story?
Yeah, the way that Kip and I met is through one of his books. And when I went to undergrad at UCLA, I had taken a number of astronomy classes. I was already very excited about the material. I never wanted to be an astronomer. I just loved the way that it challenged me to think in different ways that was different of what I was learning in my studies in art school. And then I went to Yale for an MFA, and one of the cool things about an MFA there is that they make you take classes. It's a requirement to take classes throughout the university. So I then re-enrolled in several astronomy classes, and that was really the first time that I had started to wonder if maybe the subject matter of my art itself could be science or astronomy. And so my mother gifted me a book called Black Holes and Time Warps, Einstein's Outrageous Legacy, which was Kip's incredible best-selling book. And it was the first time that all of the material that I had been learning in class came to life. Like, it was the first time that I felt as though I could really imagine what it would feel like to travel near the speed of light, to get close to a black hole. It had this very experiential quality to it, and that book was the driving force for my painting. It was a 5-foot by 16-foot painting that was in my my MFA installation here. And on the right, these are like little doodles that I was making at the time when I read Kip's book. So I felt like I knew Kip really well and that we were already collaborating at that point. He didn't know about it for another 7 years, so I think he says we've been collaborating 13 years. For me, it's closer to 20.
But fast forward 7 years, and a dear friend of both of ours, Lisa Randall from Harvard, one of the great theoretical physicists of our generation. Lisa was here on sabbatical, and at the end of her sabbatical, she threw a party for herself. And I think it was in the house that I used to live in some years ago on the corner of Arden Road and California. And so we were there at that party. Leah, as a friend of Lisa's, was invited too. And so we happened to meet. You want to describe the meeting?
Yeah, I will. We were at the party and I heard someone oversay Kip's name, and so my ears perked up immediately and I raced over and, gushingly introduced myself to Kip, telling him how influential his book had been. And there was a person at this party who was talking to Kip, who I for sure rudely interrupted, and I heard her under her breath say, "Physics groupie." We're like dying to know who this person is, so if you are that person or you know someone at that party, please let us know, because we want to complete the story at some point.
And so Leah then invites me to go to
and
her
I didn't mind. I have no shame. I was like...
No, that's true. She has no shame. So Leah invited me to go to her studio.
Yeah.
And
so not only was I like, your work was so influenced me, can you please come over immediately?
and so I went to her studio and I was just blown away by what I saw. And so let me ask you to just say a little bit about the kinds of things I saw, the kind of art that you were doing before we started working on our book.
Yeah. So at that point, right after graduate school, so it's also pretty important to know that I exist in the contemporary art world. My gallerist, Luis de Jesus, are here. I love working with them. We have a solo show up in Los Angeles, but I have existed in the world of galleries, museums. I've never done a collaboration with Kip. So some of the...
Or with any other scientist.
Well, Jan 11, but we don't want to mention that.
Yes, okay. Jan 11, I'm sorry. I'm not the first. I'm sorry.
Well, really you are, because we worked for 13 years,
okay.
So I think,
okay.
Yeah. So I just wanted to really quick kind of give a little bit of insight into sort of how I became an artist that made the things that I make. So I grew up in the Bay Area. My father is an amazing surfer and gave me my first skateboard when I was 4 or 5 years old. I have such a love of, and this will come around into a point, but my very first job in San Francisco was doing cow eye dissections at the Exploratorium, which is a very cool job for a 15-year-old. And that really set the kind of the ball in motion of how I felt that science was accessible. It was something that you were to be curious and excited about. My father's also a scientist that made this really amazing welcome into figuring things out when you don't understand something in the world. But this is sort of a foundation of me growing up. I always had skateboard ramps in my backyard. This is my biggest brag of the night. I was in Thrasher magazine in 1992. So if you know, it's very, very cool. So it's not cooler than working with you, but kind of up there, pretty close.
Thank you.
Okay. So over the years, I started to think about how science could be a part of art making. This is a long exposure astrophotography image that Adam Otke, who's here, and I made at the Volcano House in the Mojave Desert. And this started when I was awarded a grant in between my first and second year of graduate school. It was very cool. They have this like wish list grant. And I'm telling this to the students in the audience because I was in a program for painting, and it was like, what could you do for travel between your first and second year that would like change your life? And all the other students wrote that they wanted to like go to London and weep in front of the, Mark Rothko paintings. And I was like, I want to go to the darkest place on earth and look for black holes. And they definitely pitied me. I think they thought it was like the weirdest proposal they ever read. So I got this grant and spent the summer in the Atacama Desert. And one of the best things that happened there was I started doing long exposure astrophotographs. And for those of you who remember what film is, for these long exposure astrophotographs, I would take my camera, set it up, and the exposures were 36 if you wanted to use an ISO that was 800, 1600. So I started making these little doodles, and that then combined with thinking about my history of skateboarding. I was interested in making a piece that could explore the physics or motion of my body on a skateboard. So I used the same sort of setup that I did for astrophotography. This is a series called Dark Skate. I've also made a series of large-scale cyanotypes that were based on the history of women working at the Harvard Observatory at the turn of the century. Just to give you a little bit of taste of other projects that I'm doing. This is an installation at the Maryland Museum of Art, and this is at my gallery, Luis de Jesus. It's called The Sun Burns My Eyes Like Moons, really large-scale cyanotypes here. But it gives an idea of how most of my work is very research-based. So working with KIPP has been an extension of that, just another opportunity to think very deeply about a subject and use those concepts to drive what the imagery and the process are.
And so when we were at her studio and I learned about all of these things, and learned also that one of her dark skate pieces is purchased by the Guggenheim in New York. And so she has pieces in a number of eminent places like that. But I was very impressed by all this and by what I saw. And I was just on the verge of beginning a collaboration with a young filmmaker in Hollywood. That was going to be a movie set on the warp side of the universe. And so I asked Leah if she would draw for me a drawing depicting black holes and wormholes that I could show to this young filmmaker as a part of initiating the discussion about the movie. And so this is what she drew for me there as I sat and watched. I was just absolutely love it. I've used this in a number of my own publications in the years since then. This was the beginning of our collaboration.
And this is how he introduced the ask. He said, I'm working with this young filmmaker. Would you be able to visualize some of my science? I was like so excited, absolutely. And so he kept saying, this young filmmaker. And have you guys ever heard of Steven Spielberg? Anyone in the audience?
Yeah, it was Spielberg. The movie was Interstellar. Spielberg carries along more movies in the early creative phase of the movie than he can possibly make, and then he decides which one he's going to make when it comes near to starting production. He had a choice between Lincoln and Interstellar. He chose Lincoln, which was the right choice for him, I think. And then we managed to convince Christopher Nolan that he should take it over. And Steven said to me afterwards, you got the right director for your movie. But anyway, so I also showed this to Christopher Nolan, to his brother Jonah, when we started working with them on the movie. And I've used this as I say, in many, many different ways. And so that was a great start for our collaboration. But I think we should now talk about the genesis of our own book. So this is back 13 years ago. I had a great editor at Norton Publishers for the book Black Holes and Time Warps, Amy Grace Lloyd. And she had been hired by Playboy magazine to be their literary editor in this era when Playboy magazine was trying to distinguish itself from other gentlemen's magazines by having a high-class literature or articles by people who are supposedly high-class scientists or authors or what have you. And so I was invited by Amy to write an article for Playboy magazine about the warped side of the universe. She knew I was working on that since she'd edited my previous book. And I said, yes, I'd love to, but only if Leah could do paintings to go into the article. And so she and the art editor looked at Leah's paintings, and they were really enthusiastic, ravingly enthusiastic. And so they signed a contract, a commission for the article with Leah's paintings and my prose. It wasn't poetry. And so we, over a period of a few months, managed to produce an article. We had trouble confining ourselves to whatever it was, 3,000 or 4,000 words in 5 paintings. But we managed to produce it. We submitted it. And it was then looked at by this guy, Hugh Hefner, whom you may know about, who was the creator and guru of Playboy magazine. Now you can explain what Hugh Hefner did.
So Hugh Hefner then looked at the paintings that I had made, and I had the book really is the foundation, comes from the article. So I had taken my friends around me and painted them into lab techs at LIGO and working on other parts of the warped side of the universe. And Hugh Hefner looked at that and then personally rejected my paintings because I had not objectified the women properly the way that Playboy needed me to. So I often say that I wear this with a badge of honor. And for those students in here who hit a wall, this is a good... You never know where it will lead you.
And so they told us she could either change her paintings or we could just abandon her paintings and they would hire somebody to make paintings. And we told them to go shove it. And so we took our kill fee, which the contract spelled out. We got a kill fee for them having killed the article. And then we decided we'd turn it into a little book.
Which is actually a true blessing, because not only was that not the right space for this project, but Kip is right. Every time that we would see each other, it was like the project was growing at an exponential rate, and it would have been very, very hard to contain it to what it was. And we never set out to make what you will see. We called it our little book for a decade until our publisher literally said, you have to stop saying those words, because we let the book sort of tell us where it went. So this is very untraditional, where usually a writer maybe has something and then an artist comes in to fill in the gaps. What you have is really the product of our friendship and our conversations. So Kip would come over and tell me something, then I would make paintings. Then you would sometimes paint or draw on top of them?
But very early on in this process, a friend of Leah's laid the original article with a little bit of additional stuff as it was just starting to grow, laid it out as a little book. And on one pair of facing pages, in laying it out, she broke my prose, which was very carefully polished. When I'm writing like this, I try to make the prose flow really nicely. Broke it up into what looked like stanzas alongside the paintings. And I looked at that, the stanzas beside paintings, and said to myself, I had an epiphany. I said, this could be verse. It could be poetry. And I have a really brilliant epiphany only once every several years, and this was one of those really brilliant epiphanies. And so I decided I would try to turn it into verse. And so that's how we actually got started and wound up with verse rather than with prose.
It was also exciting for me because the verse or the prose were so separate from the paintings. It's almost like we had like a word file and then we had a pile of paintings.
When it was prose.
Right.
But once it got converted into verse, suddenly the paintings and the verse were really tightly coupled.
Yeah.
Because, I mean, the verse is more intense, it's more brief, it captures a vision in much the same way as a painting does. And with the two of them working and collaborating together, it just felt completely different.
And I think for me, I also recognized that it was actually doing a third thing. It wasn't just having the words and having the images, but it actually, on this layout, it transformed into something else that was close to what I felt when I read Kip's original book. And so the conversation that we always would go back to or anchor ourselves when we were creating this is that we weren't out to make anything that was didactic. It was this wide invitation to the experience of the universe through paintings and verse that were really integrated and intertwined to make this powerful kind of gesture about the ethos of science.
Yeah, and so what I came to understand fairly quickly is that this combination of verse and paintings tightly integrated really was a powerful way to convey the essence of the science that I was trying to convey to the reader, the ethos of the science, not the details. Because it's much more terse, no way you're going to talk about the fine details like I do in Black Holes and Time Warps, or when I'm writing normally for non-scientists about these things. But instead, you capture the feeling of it. You capture the central ideas, the central concepts. But in fact, when Leah made the decision to use her wife, Felicia, as the lone individual space traveler in this book, suddenly it became also something that was very human. Somehow the science became much more human with Felicia experiencing the various kinds of space-time warpages that appear in the book. So it is truly unlike anything I've ever tried before, or anything I've actually seen in terms of science communication. I sort of feel like it's a new kind of genre.
Well, also, if you think about black holes and wormholes, you're not thinking about poetry and paintings. And so this idea of having, making the choice to have one space traveler, that was my wife, Felicia, there's also something that's really joyful, full of love, full of intimacy that we hope that you'll be excited by in this book that is very different than most books.
Let me just say a few words about the verse. I never had before tried to write any poetry except an occasional love note to my wife. And so this was really new for me. But as a child, I had absolutely idolized the poetry of Robert Service, the Bard of the Yukon, he was called, such as the cremation of Sam McGee, which begins, there were strange things done in the midnight sun by the men who moil for gold. It has a certain rhythm about it that really captures me, captivates me. And so I tried to pattern what they call the meter, technically, the rhythm, the cadence of the verse after Robert's Service, but making it much more loose, not nearly as tight a cadence as he uses. I didn't attempt to rhyme because I just didn't think I could get the ideas across that I wanted to, the essence across that I wanted to, if I was confining myself more tightly by rhyming. But the cadence, the rhythm of it, for me, it's a big part of the verse and of the verse's integration with the paintings. I did get very valuable advice from people who knew poetry extremely well or were poets, particularly Jenny Joy LaBelle here at Caltech, who was, of course, one of the really great scholars of William Blake, the poet William Blake, and Diane Ackerman at Cornell particularly. And so I did need that kind of advice, and I got it, fortunately. The process of making the paintings, I think, is a really interesting process. Can you talk about that?
I think, do we have let's show the video, and then I'll
Okay.
talk a little bit about it afterwards. I'll just show you. So that little video gives you an idea of the scale of them. These are kind of the smallest pieces that I've worked on, but they are made.
They had to be small because she was going to do hundreds of them.
Exactly. This is really fantastic working with Kip. It's very, very iterative, and they're made, as you saw, really quickly. They're ink on a plastic-infused paper, so they have an incredible way of moving and letting the ink kind of flow around. But the process of making them together was this back and forth conversation. That's probably kind of the most important aspect of the process of these. We're up over about 660 paintings total were made over 13 years. 100 of those paintings appear final in the book. And then additionally, there's pages that it's like an abstract painting where only text floats. Those are also separate paintings. So in total, there's over 200 paintings in the book. But to make each one, we would have a conversation. Kip would not ever tell me to paint something specific, but sort of tell me a concept. And then that would lead me to make kind of a first gesture. I actually didn't make any sketches. Like each one was kind of an attempt to get there on its own. And like I said in that video, it's like the ink sort of does something on its own. I'm coaching it, but then there's this kind of magical trifecta where it all works together.
Well, I should say with regard to the initial idea for the paintings, the language of nature is mathematics. The laws of nature, the laws of physics are written in the language of mathematics. However, I, as a physicist, when I'm trying to do research, if I use the mathematics as my sole tool, I move at a crawl, less than a crawl. It's very, very slow, but you know what you're doing. If you really understand the physical laws, you know that what you're doing is right. But if you want to do research and really make huge progress, you have to have intuitive leaps. Those intuitive leaps tell you what kind of a calculation is worth doing, because it's going to really teach you something. And intuition, for me, as with Stephen Hawking, is based entirely on mental pictures. And so, in fact, when I'm thinking about science, I'm almost always thinking in terms of pictures, not in terms of mathematics. I only go back to mathematics when I need to make sure I'm getting the details right. And so, when I feed some ideas to Leah, and we talk about what things look like, I'm feeding her basically the picture, some version of the pictures that I'm holding in my head when I'm trying to get leaps of intuition. But she then will take what I feed her, and she makes it ever so much better picture than I had in my own head. And then we iterate back and forth, and it's really just a marvelous experience.
But you kind of have a secret life as an artist. I didn't even know this until recently. Can you share a little bit about your art class? And
when I arrived here in the autumn of 1958 as a freshman, that was the last year that it was required of all freshmen that they take a course in engineering drawing. And this was left over from the old Caltech. And it was perhaps the best course I ever took at Caltech, because I learned perspective. I got a real deep understanding of perspective. And it helped me both in my mental pictures as a physicist, in my drawings for technical publications, and in communicating with Leah. And some of you may know my book, The Science of Interstellar. A number of the drawings in there are my hand drawings, well, hand drawings with the help of a straight edge, but I did a number of those drawings myself in colored pencil. And yeah, so I...
Which even I just found out. I was like, we've been working together for 13 years. You didn't tell me your picture painting, your drawings and your books.
I told her while we were in Brooklyn a few days ago.
Yeah. And a lot of some of my favorite notes are when I've made a painting and Kip would come and draw on top of my drawings. And that really shows a kind of thought process. So this is just one example where we put together a kind of evolution of how a painting goes to final. So one of the most mind-boggling, from the non-scientists in the room here, mind-boggling things about black holes is its singularity. When I first learned about it, something that's infinitely dense, infinitely massive. I mean, all those words together, what does that actually mean? And now Kip has, during our process, Kip has mentioned that there's a lot of new information about black holes and tendencies and vortices that you'll find in the book. It's not just, it's like it actually contains a lot of cutting edge science, and there's one section that has to do with multiple singularities. And so we wanted to share with you the different iterations of
You want to control this, or
Sure.
am I going to control it?
Okay, here we go. So this is just one example where there's probably 10 or 12 different versions. And each one of these, Kip would sometimes just be in the studio watching me paint, or come over to my studio, tell me something totally mind-blowing. I like to say, after Kip left my studio, my head would feel hot for a little bit while. And then from there, it really was not, it wasn't through notes, it was just through this kind of back and forth of visuals, of nudging something a little bit this way, a little bit that way, and getting closer and closer to what you finally see in the book, which is this piece of Felicia falling through between two singularities.
So during the period when we were working on the book, these last 13 years, the two different projects that I was intimately involved with reached fruition. And they each brought us fabulous new insights into the warp side of our universe. One of these, with which most of you are probably familiar, was the LIGO project for the discovery of gravitational waves. And the big motivation for me of trying to see gravitational waves, create gravitational wave astronomy, was that gravitational waves are made from the same thing as the warp side of our universe. And we had no personal experience of the warp side of our universe before. We just were quite sure that it was there, that there were these objects and phenomena made from warp space-time. But because a gravitational wave, it consists of a stretching and squeezing of space in some sort of temporal pattern that carries an image of what's going on to produce the source. Because the gravitational waves are made from a warping of space, they are the ideal tool for observing and studying the warp side of the universe. And so that, for me, was the biggest payoff that we were going to have from this, was we would finally be able to have personal human experience of the warp side of the universe, and understand things like colliding black holes that are on the warp side of the universe. The second thing was that we did not know how to solve Einstein's equations, which predict what happens, say, when black holes collide. And so we didn't really know quite with any precision what LIGO's gravitational waves that it saw would look like if they were coming, say, from colliding black holes. And so it was essential, in order to understand that, to do computer simulations. And for that purpose, I spearheaded also creating here at Caltech, in collaboration with Saul Tucholsky's group at Cornell, a collaboration in numerical relativity to do these computer simulations and see what I like to call the a storm in the shape of space and the rate of flow of time that occurs when black holes collide, and that gives rise to the gravitational waves that LIGO is going to see. And of course, LIGO did then, in 2015, with these two observatories, one in Louisiana, the other in Hanford, Washington, did see the gravitational waves. There was a fleet of 1,000 people. The phrase "fleet of 1,000 people" is a phrase that Leah and I use in our book, that pulled this off after it had been initiated by a much smaller set of us at Caltech and MIT. And in the final payoff period of this past decade, the leadership was David Reitze here at Caltech, who is the executive director of the LIGO laboratory, and Albert Lazzarini, the deputy director. I just wanted to bring them up particularly because the book focuses on the earlier years when we were struggling to get LIGO going, and that was where Barry Barish and Ray Weiss and I were the central people. And in the end, it was Barry and Ray and I that got the prize, but it should have gone to the entire team that pulled it off, and to, in particular, the leaders that led that team that pulled it off. And so there is a discussion of that whole issue of the prize and its implications, and how the Nobel Committee got it all wrong in our book.
Kip didn't want to put anything about the Nobel Prize in the book. I had to make the paintings and say, please write about this.
She forced me to put it in, and so anyway. So I want finally, as we come to the end of this discussion, and we can go over to question and answer, I want to give you just a little bit of a sense of the things we learned from the computer simulations of colliding black holes. So this is a painting that Leah did of the black hole collisions. And the simulations of colliding black holes, the first attempts to do this were at Princeton University in the 1950s. So that's basically 70 years ago. The payoff finally came in this SXS collaboration about 2 years before the gravity waves were seen. And so that payoff came while we were writing the book. And the insights about things that we call vortices of twisting space and tendencies that stretch and squeeze, and how they make up gravitational waves, and how they are produced by the colliding black holes, all of these insights came off of those computer simulations. So I do also want to acknowledge the leaders of this SXS simulating extreme space-times collaboration, which is less well known than LIGO, but was absolutely central to understanding how the warp side of the universe behaves. Saul Tucholsky and Mark Scheel here at Caltech, Larry Kidder at Cornell, and Saul is joint between Caltech and Cornell, and then Harold Pfeiffer, who's at the Albert Einstein Institute in Germany. And they led this, but we had to create, in order to pull this off, a team of 30 people, graduate students and research physicists, to pull off the simulations. They were so extremely difficult. Getting the science out about the warp side of the universe was done largely by some of those people and by some other people, but largely students and postdocs, or former students and postdocs of myself, or students and postdocs of students and of former students and postdocs. This is multi-generational, and so these are some of those people who pulled it off. And I just want to end here this discussion by giving you a bit of poetry and paintings about what we pulled out of those simulations. So I have to pull this up a little closer to my eyes. So just as the Earth spins round its poles, so also a black hole rotates. The hole's rotation makes space around it swirl like air inside a tornado. And just as the swirling air drags all the tornado can catch, cats and cows and cars and clocks, so also a black hole swirl drags everything nearby into a whirl around the hole, fast near the hole's horizon, languid far away. As Felicia, aghast, falls feet first, apologies again, Felicia, into the spin of a black hole's north pole, Her feet nearer the hole in her head get dragged around more strongly, so her lovely body gets twisted. Her eyes see her feet turn clockwise, and her feet see her head turn clockwise, so the swirl near the hole's north pole comprises a clockwise vortex of twisting space bound to the hole's horizon. On the other side, the south pole side of the rapidly spinning black hole, a counterclockwise vortex of rapidly twisting space bound to the hole's horizon twists all that passes through. We didn't know about these vortices of twisting space until we started doing these computer simulations with the SXS team. We didn't know about it when we started writing this book. And so, but the vortices of twisting space are just appear in huge numbers of places inside this book. Now, there's another little section where we describe how the gravitational waves are generated. And I'm going to describe just one of the ways. There are two different ways, but just to give you some sense of what we discovered from the computer simulations and what we explain, Leah and I, through paintings and verse. Two spinning black holes orbit each other, identical holes that happen to spin round axes that lie in their orbital plane. A being inspecting our brain from the bulk, from a higher dimension, sees the hole's funnel stretch downward. From the top of each funnel, the black hole horizon, two spin-induced vortices come into view with equal but opposite twists. As the holes circle around one another, their vortices bend backward, trailing out spirals of twisting space, like water swinging outward from a whirling sprinkler heads. Each of the spiraling vortices sweeps outward at the speed of light, creating by its motion tendices that stretch and squeeze, tendices entwining with their vortex parents, a gravitational wave. So tendices that stretch and squeeze are also a discovery that came out of these simulations. And for the physicists here, it turns out that the tendices and the vortices are physical manifestations of the Riemann curvature tensor in the same way as electric and magnetic fields are physical manifestations of the electromagnetic field tensor. We didn't understand this before the simulations. We then went back to the mathematics and saw it in the mathematics analytically afterwards. These outward sweeping let me see. So each of the spiraling vortices sweeps outward at the speed of light, creating by its motion tendencies that stretch and squeeze, tendencies entwining with their vortex parents, a gravitational wave. So it turns out gravitational waves are entwining vortices that twist and tendencies that stretch and squeeze, all entwining together. But LIGO only has the capability of seeing the stretch and squeeze, but not the twisting space. And so I'm going to stop at that. I just wanted to for the Caltech audience, to give some sense that we are discovering this stuff through simulations that is central to the book and appears extensively throughout the book while all of this was going on. So let me just wind up in conclusion by saying that there is a great richness of science when one digs deeply into our book. However, such as the details of how the gravitational waves are produced in vortices and tendencies. But our goal is, in the book, is conveying the essence and the ethos and the beauty of science, of the warp side of our universe. And it is not the details that are there that you can find and you can dig out as you read, if you wish. But the important thing is the central ideas and the humanization of the central ideas, thanks to Felicia and Leah. Okay. And we'll now turn this over for questions.
Well, I hope that many of you saw the slide at the beginning prior to these two wonderful people coming out here where it was talking about STEM and STEAM. STEAM is the mantra of a lot of folks in the arts that want to make sure that all good STEM educators get a good arts education as well. And here we're seeing the product of the blending of art and science and how it helps to make it that much clearer to us through the multitudes of ways that we get to absorb from the prose, from the poetry, from the artwork, it all works together. We've got a number of questions, but before we do, let's give a big hand to Kip Thorne and Leah Halloran. We have questions, including one from a first-year student. Now, where did that one go? Here it is. After decades in strictly science and astrophysics, how did you know you wanted to pursue something in humanities? How could one pursue both at the same time? This came from Sophia Andrews.
Well, I tell Kip all the time he's not a very good retired person.
Yeah, I did retire in 2009. But I retired because I had been a conventional professor for nearly 50 years. And I thoroughly enjoyed it and thoroughly enjoyed working with my graduate students, with undergraduates, teaching, doing research. But I wanted to do something with the latter part of my life. And I had made the choice fairly early on that I would try to do some things at the interface between the arts and the sciences, because I do love the arts. And so I made a gradual transition beginning when I retired into that. But what I have chosen to do is I was just watch for unexpected opportunities. This has been a big part of how I have approached my career as well as a physicist. Unexpected opportunities come along, you look at them carefully, you explore them a little bit, and then you grab them if they really look exciting and fun. And so I had no intention to be involved with Hollywood at all, but I wound up doing this movie, Interstellar. I had no intention to ever collaborate with a painter, but I met Leah, and well, you've heard the story. I had no intention to write poetry, but here I am, sort of a poet. I had no intention to collaborate with musicians, but I did wind up in a collaboration that we can talk about on another occasion with Hans Zimmer, a composer in Hollywood, on multimedia concerts. So
They've probably never heard of that guy either.
Yeah, yeah. Well, and another guy, a friend of mine, whom my wife Carolee and I were at his concert last night, a guy named Brian May. And so Brian was a guest artist in one of our multimedia concerts some years ago. So he's lead guitarist for Queen. And so I just watch for unexpected opportunities. And these opportunities, all of them, I have crafted them so they tie into the warp side of the universe. And I have used them to try to inspire people about science.
We've got another one here that was, what was the hardest concept to visualize and describe in the book?
There were many things that Kip would present to me as either a challenge, and I would use sort of visualization of almost reiterating what he said back to me. Probably my favorite example is there's a chapter called Leah's Time Machine Story, where he told me something that made my head hot. And for me to understand it, I had to tell him a story back. Probably the most perplexing was...
And then I wrote the verse to go along with her story.
Right, he was writing about me trying to figure out what he was saying. It's really the chapter. But then there was another thing where...
Yeah, so I asked her to please draw a picture of quantum fluctuations.
And I said,
vacuum fluctuations.
Yeah, and I
quantum fluctuations of the vacuum, because vacuum fluctuations are absolutely central to holding a wormhole open, if it's possible at all. That's how you do it. They are absolutely central to how LIGO works in this particular generation of LIGO, manipulating and controlling vacuum fluctuations, whatever they are. And there's a beautiful description of vacuum fluctuations in the book, and beautiful paintings by Leah of what vacuum fluctuations are.
But let's back up to the first time you said this to me, and I said, well, what does that look like? And Kip very happily said, well, you're about to show me.
Because vacuum fluctuations are something that I understand mathematically. I have some vague notion, but I didn't really have any idea how to try to convey the idea to a non-scientist. And so Leah found a lovely way to do it that
If
I
anyone
bought
finds a
into.
better way, please let me know. I'd love to see your ideas.
Well, here's another one. Anonymous has asked so many questions, it's kind of crazy here. Kip, what development in the field are you looking forward to the most and to next? Where do we go from the discovery of gravitational waves?
I've always wondered this as well, like if we didn't publish our book now and it took 18 years, what would be in our book? I'll add on to that question.
Whatever's discovered in the next 18 years. This issue is addressed in the book and addressed quite vigorously. The thing I'm really looking forward to is seeing definitively gravitational waves from the birth of the universe and using those to explore details of the birth of the universe and to explore details of the laws of physics that control the birth of the universe, which are the laws of quantum gravity. And so I'll use that to whet your appetite, but that is the central thing of the very last part of the book. That's the climax of the book. It's the vision that that's what we're going to be doing with gravitational waves in the next few decades.
Leah, this one I think must be directed to you. How do you develop intuition to mentally visualize physics concepts that are so far away from the human experience?
I use the human experience to get close to those ideas. I think that's what, that has not changed. Very similarly to when I first read Kip's book, and it got me really passionate about the idea that art and science could be so close, right? It's just so much about the foundational curiosity about understanding the world. I get that question like, art and science, are they opposed? Are they on different teams? I really see them together. And for me to do that, I have to kind of envision my own body in it. You know, even notions of scale, like the class that I wrote relative to you, it was such an exciting topic because both artists and scientists have to like think about scale in different ways. It kind of doesn't really matter what you're majoring in. You have to contend with it at some point. So even doing things on a grand scale, things like gravitational waves that we're never going to be able to see and observe, to me, the idea of like an embodiment, which is, again,
Boy, that's...
if you answer this correctly, I could possibly hire you to teach at Chapman next semester.
I think I'd rather teach here, but maybe I could try to teach here again.
I see an art course team taught here, maybe?
Well, I think perspective, as I learned it in this engineering drawing course, is the first thing and the most important thing in terms of, I've forgotten the question, but the answer is perspective.
That's a good answer for the question. I know that you've already, this is another one from Anonymous, I know that you have already spoken about the book on various campuses on the East Coast. Has anything surprised you during your presentations?
Well, I learned that Kip had made all these drawings that he's already published. He's already an artist, and he hadn't told me this in 13 years.
Yeah. Well, yeah, I have to have some secrets.
Yeah. I also learned that we both learned in one interview that we both, our very first jobs, we both had paper routes. So maybe the answer to all this is that, you know, just get a job that you like really early on.
Well, I think the other thing that collaborating on this book has been enormous fun and very satisfying. But collaborating in this kind of a discussion turns out to be a lot of fun too. It has different aspects to it, but I just love doing things with you, Leah.
Well, we'll have to make another project after this.
Yeah.
Here's another one. The process of articulating science, let alone physics, in prose is already challenging. Did you find it easier, harder, or just different to use poetry?
I find it different using poetry. I find crafting poetry is much harder than crafting ordinary prose. But the surprise to me was that I could use it to get much more deep into the essence of the science. When I was teaching my students how to write, and I put a huge amount of effort into teaching my graduate students how to write, because communicating your ideas and your discoveries is absolutely central to having them have an impact in the world. I worked very hard to teach them how to, the difference between technical writing and writing, non-technical writing. That technical writing, you want to use a lot of parallel structure, which is awfully boring in non-technical writing, for example. And so I found myself sort of trying to understand verse and how that also was different, and what were strategies in writing verse, and how do you manage to get the meter, the cadence that you want, and get the cadence to somehow integrate with the ideas that I'm trying to get across. And I think I've really only begun to master this, but it is a lot hard, a lot of sweat, but also a lot of satisfaction when I do feel for myself like I've gotten something really right, and that it really fits, the cadence fits the science, and the cadence, the shifts in cadence that as I move from one idea to another, help in conveying the ideas. It's hard for me to describe this because I haven't thought about it all that much. I'm very early on in this process, and I want to do some other things with my life, and so I don't know whether I'll do much more poetry or not, but I have really enjoyed struggling to see how to make it work.
And I've been given the signal that we've only got time for this last question. Leah, your work is available, I'm assuming, in a number of different places to be seen. You have a gallery that represents you. Will these works that were used in the book also be available for sale? Will people be able to, who are collectors, be able to purchase them?
So there's a solo show up now at Luis de Jesus, Los Angeles.
It's on the screen.
Oh, it's not. Those are for questions.
Oh, no.
We have a last slide
We
with the
upstaged
gallery
you.
name. But you can see the artworks at the gallery. There's about 1/3 of the book. The original work for the book is not for sale, but you can buy a print from the book. There's a QR code you can scan. You can also get it in the gallery. And go see the show in person. We're going to have a smaller event that's on December 16th. That's going to be us in conversation, and we'll talk about even like making the pieces. It was actually really exciting for both of us, kind of unbelievable, but after 13 years, we had never hung up even one piece on one of my studio walls because we just kind of used them to pass back and forth to create the book. So it's a really nice exhibition to see the work from the book. There are a collection of other pieces that I've taken in celebration of each of the chapters and made a larger piece to expand, and those pieces are for sale. So you go see them in person. Good. Great.
And you can all now join us outside where the books will be available for sale. Kip and Leah will be there to autograph them. And we also understand that you are going to be, for those of you who want to tell your friends that there are other opportunities to hear them talk about the book, you're going to be at the Griffith Park Observatory shortly.
December 14th at Griffith Park.
December 14th at the Griffith Park Observatory. And we want to thank Kip and Leah from the bottom of our hearts for joining us.
Before
One more
you
pitch.
thank us, let me make one remark. I had COVID. I developed heart problems from the COVID, so I don't want to catch it again. And so that's why we're doing the signing outdoors. And I'm going to be separated from other people except when you come up to have your book signed. So that's the reason for this sort of layout that I'm not. I used to interact eagerly with a large crowd of people around me, but not anymore, at least not until we figure out what's going on with my heart. So thanks.
So you're not playing the bandit if you're wearing a mask.
Yeah, I'll wear a mask, but I'll take it off for selfies.
Okay, good for you.
Thank you so much.
We look forward to your joining us again. Remember to go to events.caltech.edu for further information about the public events presented here at Beckman Auditorium. Thank you all.